In 1935, after a plan that had been kept secret in advance, 102 cane toads from Hawaii were brought to Australia by entomologist Reginald Montgomery. Not long afterward, they arrived at fields that had been devastated. The plants that were not already dead had turned yellow, their stalks dry and withered. Dr. Henry William Kerr, director of the Bureau of Sugar Experiment Stations, personally opened the lid of the crate. Inside, 101 large warty toads scrambled over one another to get out. They jumped wildly in every direction, and a few even slammed into Henry Williams' legs. They snapped up anything they could fit into their mouths, swallowing beetles whole, tearing apart cockroaches, and crushing the heads of lizards in their jaws. Everyone at the scene happily applauded, believing the first stage of the plan had succeeded. Everyone except one man, Walter Froggatt. In The Australian Naturalist, he had warned that these giant toads were monsters and that they would become a major disaster, no different from invasive rabbits or prickly pear cactus. But his warning was completely ignored. Nearly a century later, his prophecy had come true. Cane toads had become a permanent disaster, and Australia would never be able to eradicate them completely. So how did what seemed like a perfect solution turn into a chain of disasters? Our story begins in the same way that so many tragedies have begun. In the 19th century, the British brought sugarcane to Australia and turned it into one of the most important pillars of Queensland's economy. Across the region, vast sugarcane fields stretched into the distance. Sugar mills rose beside small towns, and horse-drawn carts and trains carrying freshly cut cane ran constantly during every harvest season. But it did not take long for the farms to suffer serious damage from cane grubs. The beetles laid their eggs in the soil, and their fat white larvae gathered around the roots, feeding on them day after day. The sugar cane began to turn yellow, became stunted, and eventually died in large numbers. When Reginald Montgomery pulled the plants from the ground, all that remained were shortened, damaged roots and grubs curled up in the soil. The farmers could do little more than stand by and watch sugarcane yields collapse. The growers were furious. They came together, approached the Australian government, and demanded that something be done. "Sir, an army of creatures is destroying our sugarcane fields." And so, in 1900, the Queensland government established the Bureau of Sugar Experiment Stations. How do you eliminate native creatures that are destroying crops while still keeping profits rising? The BSES wrestled with that question for roughly 25 years. They tried pesticides, pumped chemicals into the soil, and released parasitic fungi. But every approach failed. Some were too expensive, some were too slow, and some were almost completely useless. Then one day, while everyone in the office was still struggling with the problem, Jaman, a senior member of the BSES, had an idea. Why not use nature against nature? What about cane toads? I mean, they're frogs. They eat insects. We just need to introduce one invasive species to solve the problem caused by another. At the time, it actually sounded reasonable. In 1932, Arthur Bell returned from a conference in Puerto Rico with promising reports about Bufo marinus. They ate almost anything, reproduced quickly, worked for free 24/7, and most importantly, Hawaii had just used them successfully. So why couldn't Australia do the same? And as you saw at the beginning, just 3 years later, entomologist Reginald Montgomery traveled to Hawaii. He captured the first cane toads and brought them back to Gordonvale. But the 101 that survived were not released immediately. They were placed in specially built enclosures and bred. Now, prepare yourself for what I'm about to tell you. In less than 2 months, their almost uncontrollable reproductive ability caused their numbers to increase more than 24-fold. Yes, 2,400 toads. The entire enclosure was crawling with them, their warty backs packed together as they pushed and climbed over one another. The BSES saw an army of pest controllers that was multiplying itself for free. They began releasing them around cairns and Innisfail, but they had overlooked the most important thing. They were releasing these invaders directly into the wild, not into a laboratory. There had been no serious assessment of the ecological consequences. Entomologist Walter Froggatt spoke out forcefully and persuaded the Department of Health to issue a ban on releasing the toads in December 1935. But just as hope appeared, it was crushed. Blinded by profit, the BSES and plantation owners applied intense political pressure, eventually forcing Prime Minister Joseph Lyons to overturn the ban in September 1936. And this time, Australia's ecosystem would never be the same again. Those big, fat, slow-moving toads that spent most of their time on the ground were not exactly the smartest solution for dealing with beetles that spent much of their adult lives about 20 feet above it. The cane toads simply could not reach them. And even if those beetles had lived closer to the ground, the two still might never have crossed paths. Seriously. In Puerto Rico, the beetles typically fed on vegetation at night and returned to the soil early in the morning, giving toads a chance to catch them as they climbed up or crawled back down. But Queensland's grayback cane beetles behaved differently. Once they emerged from the ground, they could spend around 2 weeks moving between feeding sites and resting places in the plants, rarely returning to the ground. Even worse, the creatures causing the most serious damage to the sugarcane were actually the larvae underground, chewing through the roots directly beneath the toad's feet. But cane toads do not dig through the soil to hunt, so they had almost no way of reaching the most important target Australians wanted them to destroy. But the story did not end there. This was only the beginning of another disaster, one that would eventually alarm even some of the most experienced scientists. The beetles kept destroying the sugarcane. But the toads did not starve. They simply changed the menu. Other insects, snails, lizards, small rodents, young animals, if something moved and was small enough to swallow, they could try to eat it. The sugarcane fields may not have provided many of the beetles they were supposed to target, but Queensland's tropical landscape offered them something else that seemed almost endless: food. And when it comes to cane toads, you could almost call reproduction one of their weapons. In a single year, one female can produce up to 70,000 offspring. Now imagine what happens when there are millions of females. The number becomes almost impossible to picture, so imagine just a few dozen females laying eggs in the same pond. Hundreds of thousands of eggs quickly hatch into tadpoles, packed so densely together that the surface of the water can appear to turn black. A few weeks later, they grow legs, lose their tails, leave the water, and an army of young toads begins pouring onto the land. But come on, surely this still could not be that serious. Australia is home to some of the most dangerous creatures on Earth. Surely the native wildlife could handle them. No, every one of them would lose against this warty invader. But the reason why is something we will come back to later. The greatest tragedies in human history often seem to begin with a beautiful illusion. It turned out that the decline in beetle numbers in Puerto Rico was not caused by cane toads at all. The beetle population had fallen because rainfall had changed. You heard that right. When researchers look back at the data, the period when cane toad numbers surged and white grubs declined after 1931 also happened to overlap with one of the wettest periods ever recorded in Puerto Rico. These larvae live in the soil and generally cause more severe damage in drier areas, so the sharp increase in rainfall could easily have contributed to their decline. And of course, Australia had no miraculous rain like that. Instead, the situation just kept getting worse. By the way, just 10 years after cane toads were introduced into Australia, the cane beetle problem really did begin to decline. Of course, it was not because the toads were eating them or because of any biological control method. It was because of chemicals. In 1945, Reginald Montgomery, the same man who had brought cane toads from Hawaii to Queensland, began testing a new pesticide, BHC, also known as gamexane. This time, workers deliberately moved along the rows of sugarcane and applied the chemical directly into the soil, right around the root zone where the cane grubs were hiding and feeding. And it worked. By 1947, Queensland farmers could buy gamexane to treat their fields. Bags of the pesticide were shipped into sugar-growing regions and applied row by row. Within just a few years, hundreds of tons were being used across thousands of acres. BHC was later replaced by safer and more suitable chemicals. Beginning in 2001, imidacloprid also became an important tool for controlling cane grubs. At last, the beetle problem could be brought under control, but the toads that had been introduced to solve it were still there. Or more accurately, things were much worse. With such an enormous reproductive capacity, they did not remain confined to the sugarcane fields. They began spreading across Australia. In 1950, cane toads were officially declared a pest. Less than a decade later, they had already occupied much of Queensland's east coast. From there, they pushed toward the Gulf of Carpentaria, moved deep into the Northern Territory, spread across Kakadu, and eventually crossed into Western Australia. In 2009, they finally crossed the border into Western Australia, more than 1,200 miles from the place where they had originally been released. See those small raised bumps behind their shoulders? Those are the parotoid glands. When an adult cane toad feels threatened, these glands secrete a sticky white fluid, and when that toxin is swallowed, two things can happen. First, bufotenine can produce powerful hallucinogenic effects. Second, other compounds known as bufogenins can have severe effects on the heart and may even trigger cardiac failure. And here is something important to remember. These toxins are also present in their eggs and tadpoles. In the cane toad's natural range, this is not such a serious problem because the animals living alongside them have had thousands of years to adapt and learn how to deal with these toxins, either by developing resistance or by learning how to eat the toads while avoiding their toxic glands. But in Australia, a freshwater crocodile, a venomous snake, a monitor lizard, or even a northern quoll can look at a slow, fat cane toad and think it has just found an easy meal. It bites down, and sometimes that becomes its last meal. More than 75 species are directly threatened. Some northern quoll populations have been completely wiped out, triggering cascading effects throughout the food web. Humans have not been completely spared either. Cane toads invade backyards, streets, water troughs, and residential areas. Pet dogs can suffer severe poisoning after biting or licking them. Their toxic secretions can also irritate a person's eyes or mouth and may cause dangerous symptoms if swallowed, although human deaths are extremely rare. Governments and local communities have also been forced to spend money and time setting traps, collecting toads, and trying to stop them from spreading even farther. Today, no one is defending cane toads anymore. In fact, in 2010, the Australian government stated, "It is highly unlikely that there will ever be a broad-scale method capable of controlling cane toads across Australia." And now the question is no longer, how do we wipe out every population? It has become, how do we stop an entire population from continuing to reproduce? People began coming up with all kinds of ideas. In many places, residents walk along roads at night carrying flashlights, searching through patches of grass and around pond edges for active toads. They catch them by hand, collect them in buckets, bags, or containers, and then dispose of them. Some communities even organize large-scale cane toad hunts, turning invasive species control into a group activity. But the more toads people catch, the more they realize there is one frustrating problem. Catching hundreds of them may make you feel like you have won a battle, but there are still thousands more out there. Large-scale toad hunts can create another problem as well. While searching for cane toads, people may accidentally capture native amphibians too. And even if you clear an area today, cane toads from surrounding regions can simply move back in tomorrow. It is like constantly bailing water out of a boat while a hole remains open in the bottom. You can work as hard as you want, but the problem keeps coming back. The cane toad's extraordinary ability to move and reproduce has turned manual removal into a battle that seems almost impossible to finish. So researchers began thinking further ahead. If they could not catch every adult toad, why not prevent them from producing the next generation? One idea is to release sterile males into the population. These males would still compete with normal males, but when they mate, they would produce no offspring. Another idea is even more ambitious, interfering with reproduction so that populations gradually produce more males, reducing the number of females capable of breeding. In theory, this would strike directly at the machine, producing millions of new cane toads every year. But this is also where the story becomes frightening in a different way. Because once you start talking about viruses, bacteria, genes, or changes capable of affecting an entire population, you are no longer simply hunting an animal. You are trying to alter an entire ecosystem. If even one biological control method spreads beyond its original target, Australia could once again find itself paying the price for another ecological crisis. And then scientists found another approach. Target the cane toads before they ever have a chance to become adults. Cane toad tadpoles have a very unusual trait. They are strongly attracted to chemicals produced by members of their own species. Researchers began taking advantage of that behavior, turning what would normally be an attractive signal into a trap. Instead of running across enormous landscapes trying to catch individual adult toads, they began looking for ways to make the tadpoles come directly to where humans wanted them to go. But the story does not end there. This evolutionary arms race is not happening only on the side of Australia's native wildlife. Cane toads are adapting too, and they are becoming better and better at invading new territory. During the first few decades after they were released in Queensland, the invasion front expanded by only about 6 miles per year. But in more recent invasion zones, That speed has increased to more than 30 miles per year. At first, scientists suspected that the toads might be hitching rides on trucks or being accidentally transported by humans into new areas. But when Rick Shine and his colleagues fitted individual toads with radio transmitters and tracked them in the wild, they discovered something more troubling. Many of them were traveling entirely under their own power. Some individuals could move as far as about 1.1 miles in a single night. When researchers compared toads at the invasion front with populations farther behind, they found that the leading individuals often had longer legs and were better at moving across the landscape. And that created a very unusual process of natural selection. The toads that traveled the farthest reached new territory first, faced less competition, and often bred with other toads that were also especially good at dispersing. Then the next generation pushed even farther. Of course, humans were not going to simply stand by and do nothing. Australia is now also looking for ways to turn its own dry environment into a barrier against the invasion. In early 2026, Judy Dunlop, Chris Jolly, Ben Phillips, and their colleagues published a highly practical study. Instead of trying to catch every individual toad, simply prevent them from reaching water. Experiments showed that more than 99% of cane toads were unable to cross barriers 20 inches high or taller. Concrete water troughs with smooth walls and rounded edges were especially effective because the toads had almost nothing to grip onto or climb over. They were much harder to enter than plastic troughs with edges that provided better footholds. But how could a simple water trough influence an invasion stretching across hundreds of miles? Because water is the cane toad's weakness. During the wet season, they can continue moving across the landscape, but once the dry season arrives, they must find a reliable source of water to survive. A single artificial water point can even keep hundreds of cane toads alive through the dry season. The problem is that humans have accidentally created an entire chain of refueling stations for them. Cattle dams, drinking troughs, boreholes, and leaking water pipes. Across the dry stretch of land between the Kimberley and the Pilbara, many areas would be almost incapable of supporting cane toads through the dry season without these artificial water sources. That is why a plan known as the Toad Containment Zone is being developed. The idea is to create a barrier roughly 90 miles long across a geographic bottleneck between the ocean and the Great Sandy Desert, where around 150 artificial water points could be upgraded or isolated from cane toads. Livestock would still be able to drink, but the toads would not. And when the dry season arrives, any toads that have already entered the area would be unable to find the water refuges they need to survive, preventing most of them from continuing their journey toward the Pilbara. In the end, what began as a seemingly simple solution turned into a battle that has lasted for generations. Perhaps the biggest lesson of the cane toad story is not that humans should never interfere with nature, but that even a small decision inside an ecosystem can create consequences far greater than the problem we were trying to fix. If you had been the person making that decision in 1935, with no way of knowing what would happen next, would you have released those toads? Let us know in the comments. And if you enjoy stories about the strange battles between humans and nature, subscribe to the channel so you do not miss the next video. Because this story is not over yet. Could there be an animal or a method that can finally defeat the cane toad? That is exactly what we are going to explore next.